You should be hearing something. It'll take 45 seconds. This is an audio test. We are testing audio. Delay. Yeah, 45 seconds.
So welcome to the third RASP meetup for 2018. My name is Farshad Abbasi, for those of you who I have not met. Yeah, thank you for coming. Our speaker for today is Roger Trevisan. He's going to talk about transitioning into DevSecOps and everything that goes along with it. Roger is a CISSP certified professional with 12 plus years of experience with web application security, secure coding, secure development lifecycle, penetration testing, risk assessment, vulnerability management, network security, and information systems administration. So Roger knows a lot of stuff. As a skilled pen tester and application security professional, he has helped high-profile companies in industries such as financial, healthcare, and telecommunication to identify and address a large number of critical security vulnerabilities. Roger and I worked at HSBC together for a number of years, and we currently work together at Mirai Security. So I'll stop right there, and I'll pass everything over to Roger, who's going to do the presentation. Thank you.
Thank you very much, Farshad. Hello, everyone. Thank you for taking the time on this beautiful day to come here and listen to me talking about technology and DevSecOps. It's a pleasure to be speaking today. And thanks, Farshad, for organizing this and all the volunteers that made this happen. So Farshad did the long introduction about me, so I feel like this is the summary. So basically, I'm a security consultant with Mirai Security here in Vancouver. I did ops before it was ops, so system administration and running the IT, basically. I work as a dev as well. I helped develop many applications. And then at some point, I transitioned into infrastructure security, and then I learned to do penetration tests. And then later on, I transitioned to application security. And then I have kind of acquired experience on both doing ops, doing devs, then securing ops and securing dev. And application security is now what I currently do most of the time. And one of the funny things is that before I started working on IT, I actually worked on an actual factory, a furniture factory. So when we hear about DevOps and how they borrow manufacturing ideas and concepts into software, well, I learned all that, and I was doing one of my mottos and how I gain trust from my clients is, well, we can automate everything, and we did automate a whole bunch of things before DevSecOps. So it was kind of not having a pipeline, but it was still automating all the scans and all the securing and policies and everything in between for a bunch of companies. And now it's a good feeling to have this actually happening in security. It's like, well, I can speak about this. So this presentation, it may sound like I know a lot about DevSecOps, but I don't really claim to be a specialist on it because nobody really is. I would be sketchy of someone claiming to be a DevSecOps specialist. It's such a new area that is still being developed. So there is lots to be learned and lots to be developed. So my presentation is more a summary of what's out there, best practices, and what other people are doing, and how we got there. So what we're going to talk about is how we did things before DevSecOps, what is Dev, what is Ops, and what is the role of security in there. And then we have this transition. This is a really interesting portion, security and DevOps. Note that this is not DevSecOps. So there is this in between where we still do traditional security, trying to bolt it on DevOps, which is not really following the DevSecOps manifesto and guidance. So we'll talk a little bit about there, and then we're going to dive a little bit deeper into DevSecOps and see what is this thing all about. And then we're going to learn a little bit about the challenges we still have and some final takeaways from this speak. Please forgive me if I don't speak perfect English. It's my second language, so Portuguese is my first language, and this is my first international speech, so it's going to be interesting. So before DevSecOps, so we had something, if you've been in this industry long enough, that was called waterfall. So very, very, very long cycles. You plan everything, what exactly you want to build, then you build everything, then you test everything, then you go and scan everything, and then if you find bugs, you go back and you try to adjust or fix bugs on a very large piece of code. And the beauty about that is that you have the development team. Those guys are very large organization. Usually most people in a company are devs. Then you have the ops team. These guys are usually hidden in the data center somewhere. They are not anywhere near sight of the developers. And they don't really communicate. And then you have the security. These guys are usually locked in a room. I was literally working locked in a room for many years so that we don't talk to other people, right? So you see where this is going. There is no communication. I have my interest as a security person. I want to make everything secure. I'm going to write policies for it. And I'm going to go after software that's not following those policies, and I'm trying to fix it and propose solutions and present reports on how bad it is so that developers can fix it. At the same time, you have ops. that I have another security person that's running security operations, monitoring things, finding bugs, and letting the ops team know that something is wrong with their organization and they need to fix it. So let's dive a little bit deeper into this construct. What the traditional dev wanted on a traditional waterfall sort of SDLC. So they wanted to write code, make it work, and move on. They wanted to work with new and exciting technology. Who doesn't, right? I don't want to write code in Next or whatever old language you may remember. I don't know. Old languages. They want to innovate. They want to have the latest and greatest. They want to follow the technology. They want to do cool stuff. They have some pressure from management. So these guys, they have maybe sales team. They have the CEO receiving feedback from the customers, and the customer wants some feature. They let those features be known to development management, and they build it, and that's cool. And they want to do it faster. They are not responsible for security. Something goes wrong. Hey, we got hacked. Who do we call? Call security. Nobody calls the development team. Development team is at home, or maybe researching something, I don't know, doing something fun, while security team is trying to find out how we got hacked. They are not responsible for running what they wrote as well. They build it, it compiles, it works, I create an installer, and I'm done. Send it off to operation teams. They're gonna run this thing, right? So operation teams want something else. They want something that's easy to deploy. They want to deploy easily, quickly. They don't want too much headache. They are already very busy updating servers and rebuilding stuff. They want something that is stable, that doesn't give too much problem, right? And they want technology that integrates well with the tools that they have. Maybe they already have some monitoring tools that collects logs in a certain format, and then developers come up with this brand new technology that doesn't really work with whatever they have. If something doesn't work and is not security related, system is down. Who gets the call from the angry customer? Is usually ops, right? Developers are still creating brand new stuff. Ops is dealing with the fallout. Like something goes wrong, ops gets the call, right? They don't want any unplanned work that might upset the environment. Who creates unplanned work? Patch Tuesday. Like security guys show up with that little report, like, hey, we need to apply these patches. They are all critical. They came out today, and we need to do it. You have until midnight. Just do it, right? That's unplanned. They didn't have the people. They didn't do the research. They don't know if it's going to break it. Sometimes they have legacy technology. They have that one server that's one of a kind. There's no virtual environment for it. And they don't know, like, if I apply this patch, is it going to crash? Is it going to survive? Even if I reboot this thing, is it going to reboot? I don't know. Let's just try. They hate that stuff. Another thing that they want is get rid of those old, exotic, unsupported technology. That means problems for operations, right? It's difficult to run that. If you have things that are one of a kind, well, it doesn't integrate well. Ops like patterns. They want everything standard. That's how they is easier to maintain. So like I said before, they run what developers create. They're in the front line. They get the call, and they are okay. They actually appreciate security as long as it doesn't destroy their environment, right? Traditional security is a little bit funny. All that we want is software security assurance. We want to make sure that the software is secure and it's good enough. we need to know how far is good enough, how good is good enough. That is defined usually in a policy, like when I have this level of scans, this many penetration tests, and the results are all clean, then I'm confident that this software is secure. That's security assurance, right? But the thing is, we are not really, at this point, we're not really included in the decisions. We may write however many policies we want, we try to train people, but development is not really interested. Like when they get the requirements from the business folks, from sales team, product requirements, it's functional requirements, not really security. No business guy is going to walk downstairs and ask the developers, hey, can you implement this encryption on my software? Nobody's going to do that. It doesn't really aggregate value to the software. Like, am I going to sell more because I have this cool security feature? Probably not. It's just everybody else does without security, so why am I going to spend money on that? But we security guys are there trying to push this stuff. We want to help build security. We create policies, we create security programs, and we try to enforce them. How do we do that? We do security scans, and then we take that scan with 1,000 vulnerabilities, and we drop at the developer's desk. Fix it, right? We are not the ones fixing. It's very easy, click a button, run a scan, and dump it on a development team. Our requirements usually, like we have this security policies, right? Security teams are usually on a corporate level. They are not connected to the product development level. There is many products being developed in our organization, right? So security team is up here trying to secure the whole organization, not just one specific product. So our policies are very generic, and they are usually a little bit paranoid it's for the good of the organization, but sometimes it's too extreme if your product doesn't require that level of security. So it may be a little bit disconnected from what certain products are trying to achieve. So sometimes they don't need all that security. They need a little bit less. And we are not invited for planning or security requirements. If any of you work on a security team and you were invited for security requirements on a planning stage for software, congratulations, because you work on a very, very advanced organization. I've never seen this. Like, well, I would be lying if I say I've never seen it. I've seen very few times. It's not often. And when thing goes wrong, so penetration tests, for example, so we don't have much planning in advance. So we, every 6 months or every once a year, we invited a penetration testing team to go and find issues for us, right? Guess what happens? They find issues, and someone has to fix. Nobody planned for that. Sometimes those issues are very difficult to fix, take a long time, take a lot of investment, and it was not planned. Unplanned work is the worst thing you can have in an IT environment. It takes so much time, and it takes the happiness out of the room. It sucks the happiness out. So there's got to be a better way to do this thing, right? Dev and Ops figure out a way to work together, and that's DevOps, right? So they figure that, hey, I'm a developer. When I write my code and I have to deploy it to my testing service, I already write some scripts to automate that. I want to compile my code and push it to my spin up a virtual box or a container or something, Docker, and run my code as fast as I can and as easy as possible, right? So they figure out, hey, maybe this can help operation team. Maybe we can automate the deployment of this thing. It's a good idea. And then DevOps was born. So developers leave hooks and tooling for operation teams to run the software. And it started with agile and frequent deployments, and it kind of evolved into this beautiful thing that both teams actually made friends and started working together. So now operations say, hey, it would be cool if your logging was in this specific format so that I can integrate with this tool that I have, and then everything will be nice. It will be much nicer. It'll be easier for me. You'll save me time. And if something goes wrong, I can detect earlier, I can let you know earlier, and we can fix. And we don't have to work on weekends, right? That's fun. So DevOps is basically a culture. It's not just tools. Like if you think it's just a pipeline and a bunch of tools, it's not. It's actually people have to make it happen. If you just have tools, it doesn't work. So it's a culture and a practice to unify software development and operations. So it's basically strongly advocate automation and monitoring at all steps of construction, or testing, releasing, deployment, everything. All the lifecycle steps of the software. And the result is that you have increased deployment frequency and more dependable release in close alignment with the business objectives. So what does that mean? Like, how do they sell this stuff to management? Like, some CEO has to approve that we buy some new tools and new servers, and that our development and management and operation management start working together and have more frequent meetings. Like, they see this stuff. How did they convince the management to buy into this? The reasons is that it speaks to what CEOs like to talk about. So you have frequent deployment, and you can do A/B testing. You can do all sorts of things, and you can experiment, right? I can develop this feature. I don't know if it's good or bad. I just spend a day or two developing it, and I push it to 1% of our customers. And then we get our feedback. We monitor how they use it. And if they don't use it at all, we just take it out. We disable that, and we build something else. And we test that again until we get the response that we want from our customers. So it's an iterative process from end to end, from development, from the ideation of the features that you want, until you have feedback. And this loop happens very fast. So you don't have to build the whole solution now and deploy it, and then have feedback just to find out, hey, customers don't like it, right? So nowadays it's very fast. And it empowers employees, like, hey, I have an idea, I want to build this cool feature. Well, you can, just build it. Push it to 100 customers, see if they like. If they don't, well, you tried. If they like, hey, great idea. Let's do more of this. You can transform products, you can try new business model, you have better time to market. I think this is one of the key, it should be up here. And you have a quick response from the market. So all things that CEOs like. But this is DevOps, right? Guess who didn't join? Huh? Who is still locked in the room? Yep, security folks, we're still locked in the room. We're still writing policies. We're still trying to do our scan. Developers build it, and then we put a scanner in between Dev and Ops, and we run that scan, and then we deliver the same report, right? 1,000 issues. Go figure out, and then we wait. And by the way, this scan usually, if you ran dynamic scan, it may take anywhere from a day to a couple weeks, right? We don't know. Penetration test, 3 weeks, 2 weeks, depending on the application and the level of penetration test you want. So it delays everything, right? So people don't like you. They don't like you one bit. Like, you, every time you walk in the room, it means problem. Red lights go off everywhere. People need to go to the bathroom very quickly. It's not fun. You go talk to their managers. Well, guess what? It costs a lot of money to fix all this stuff. You should have told us earlier. Now we have to rebuild. Like, my authorization framework is not good enough. Like, I need to rewrite the whole authorization framework. I have to change all the session management. What do you mean I cannot store the configuration in clear text on the client side. Like this is what I've been doing for years. So it becomes expensive, right? And then the next question, and I've heard this so many times, how is this feature sell? Like, guys, you're not adding value to the business. I heard this so many times. You have to understand. I understand that security is important, but I cannot sell this stuff. Like, how customers already bought the software. This is not going to change anything. It's not any. If I release a new version just with the security fixes, am I going to admit that I have security issues? Because there is no improvement. It's not faster. It's probably slower. It doesn't look any better. Doesn't add any value. It's just more secure. That doesn't really sell, right? And then the other problem that we have is sometimes security folks go really paranoid, and I'm kind of guilty of that. Like when you don't know what's going on. Like sometimes you get this product that's been for 100 years being deployed on premise, right? And then suddenly they want to do a lift and shift and put it on the cloud. I don't know what's in there. I don't even know what the code is. Am I going to trust these guys to put it on the cloud? Like even, I don't know, maybe there is some code that developers put in there. How are they going to manage the keys? How is the communication? I don't know. So I don't trust them. And I'm going to say no. So I'm not enabling the business, right? And I'm, once again, the most hated team in the organization, right? These guys, they're just messing with us. They are not letting us make money. And the cure feels much worse than the disease. Like I risk it for 10 years, I'm not going to do security now because I'm going to spend another 10 years just to fix this stuff, right? So it's difficult. Nobody wants to invite the police to the party. And I thought a lot about this, and I was the police for a long time. Like I was an enforcer. Like we need to make security. You're not going to release until we meet all the security criteria. That's it. I'm going to escalate. Things are going to take a long time, but we're going to do it, right? That's the way to do it. And it doesn't work, right? Hang on. So this one is traditional security in the DevOps and agile environment. Is more like how to make enemies in DevOps and agile environment. So just like I said before, you have your beautiful CI/CD pipeline. You want to deploy. You want to build code, cool features and all that. And then I hop in, show off with my security scanner, and I want to do a code review. It's not integrated anywhere. I'm just copying your Git repository. Still writing code. At some point in time, I take some piece of code from there, and I'm going to run a security scan, and I'm going to just deliver that report to you. And then you're not going to do anything about it because, hey, it's just a PDF. It's not injected anywhere. It's not integrated. It's not on my IDE. It's not in my defect management tool. And I don't really know. I don't really understand. As a developer, I don't really understand these issues. Cross-site scripting? No. I don't allow any scripts to have. We don't have this feature in the software, right? SQL injection, well, I use Postgres. It's on AWS. It's fine. AWS is secure, right? And then I run more. I come up with another scanner, automated application. And then by the time you want to release, so here you finish all your functional testing, it works beautifully. Performance is super fast. Everybody loves it. Who shows off waving the security checklist? Hey guys, did you think about this and that? Did you meet this policy? We're going to have compliance issues, blah, blah, blah. High risk, critical. And then people are already starting to look red and try to look away from you. It's difficult. And eventually, you're going to get someone, like maybe the CEO is going to sign off a waiver, right? Like you may fix some easy things, and then the most common thing, like the silver bullet for risk and security vulnerabilities is get the CEO to sign a risk acceptance, right? Risk acceptance is beautiful. You just show off with a paper, like, hey, I know, I acknowledge your policy. I know there's so many bugs. Just going to accept everything because we need to do some business here. And then you move on. And then at some point, security operations, the ops portion of the pipeline is going to deploy this stuff. If it's on-premise or AWS, you're going to have to talk to security operations. We found a way somehow to collect some logs, and we monitor stuff at the firewall. And we noticed that there is some configuration that doesn't really look very secure. Like we're using some protocols that are very bad, and we should close it. But we cannot, because we didn't plan for it. The system runs off that stuff. And changing it means rewriting a bunch of things. We use some libraries that are very old. It doesn't really work. So you got the picture, right? It doesn't look good. And it doesn't work because we cannot escalate. So I put compliance checklists here, but this is basically applicable to pretty much everything. How do you escalate, scale, not escalate, sorry. I make this mistake a lot. How do you scale penetration test? It requires human work, right? You have limited resources, it's expensive. You don't want to do that stuff so often that if you have 1,000 deployments a week, how are you going to do penetration tests and all that? You don't want to do that. If you have someone running a checklist, maybe you have 10 or 20 or 40 builds every day and you deploy that every day. Are you going to run a checklist against all that manually? No way. DevOps doesn't like gates. So security is usually tied to that old mentality of waterfall. You have gates, right? You have your development, then you finish development, then you test everything. If tests pass, so you have your QA check, then you go through security, everything is secure, then you have your security check, and then you're ready to package and deploy it, right? DevOps doesn't like any of that. It's hard to keep up without this. And then you have that other problem, right? The standard security operation doesn't integrate well with DevOps. We don't know the tools you guys are using are too new. Like, we don't know how to deal without that. Do we have to configure my firewall every time? How do I monitor stuff on AWS? Like, how do I secure communication between nodes on Kubernetes? No idea. I have, like, is it possible? Is it even possible to do that? I don't know. I legitimately don't know how to do that without using DevOps and DevSecOps tooling. I don't think there is a way to do that. So we need to step up. We need more data. We need to step up our game and really do DevSecOps. So basically, what is DevSecOps? So it's us, security folks, joining the party. It adds the SAC into DevOps. And it's a little more about culture, people, and organization than process as well, but more about that than tools. Like, you can do DevSecOps and have little tools, some automation. So DevSecOps is all about what they throw this term a lot around. It's shift left, right? So plan everything early, account for all the stuff that you want to see in the application, join the daily scrums, join the CCB boards, try to figure out what's going on in the development and operations, understand what these guys are doing, and then you can secure it. If you don't understand what your counterparts in dev and ops are doing, how do you expect to secure it? And a lot of people don't know. Like, I've seen application security guys that don't know how to write code. They don't know. They never wrote a piece of software ever. How can they expect to secure applications, right? If you don't understand what's going on. So basically here, the strategy is driven by learning and experimentation. So DevOps allow you to experiment a lot. Like, you can You can create parallels, and you can build stuff in different ways anytime you want. You can do A/B testing. You can throw things in different environments, and it's so easy, right? It's one click of a button, you deploy the test environment, and then you test whatever tool you want to test, and then you kill it, and then it's done. And in a couple hours, you can do that. And that gives us opportunity to learn and improve. So security now is part of the development lifecycle. We join the meetings. We are invited to be part of the team. And this is the culture part. If we don't buy into the friendship of Dev and Ops, we cannot make DevSecOps, right? If they don't trust us, if we show up with that attitude of the police, right? If we show up as a police officer, hey, you're not following the policy, they're going to kick us out very quickly. They're going to just forget about us. We're never going to get an invite to their meetings again. And the other beautiful thing is security now is code, right? So your policy is now code. So you don't throw that report around anymore. You write code to evaluate that report and make a decision if the build is good enough or if it's not, if it meets the policy, if it doesn't meet the policy, if you can flag that build as good or as bad, and report back to the developers. That's all automatically. And then when you have code, it's all, you can scale, right? You can deploy the same code over and over. You can build patterns, and you can reuse that stuff for all the products. Oh, and the other thing is it spans over the whole CI/CD. So I'll talk mostly here about the CI, right, is where you're creating the software, but then you have the operations part. So you have security operations as well. You have to run that stuff. You have to monitor it, and you have to gather information, right, about what the application is doing, and then you have to account for that at the very beginning. If the application doesn't give a good quality logs, you're not going to get the monitoring capabilities that you want to have. So the DevSecOps is very similar to DevOps. It's developing safer software sooner by involving everybody in the creating process and practicing continuous improvement from high fidelity, actionable feedback with context. And this last part here is key, right? I have lost count of how many conversations I had with my own security teams about, hey guys, don't show up to the developers with these low risk issues. Like, who cares if the variable is instanced in the code and never used? How is that a risk? It might use a little bit, like a tiny little bit more memory, but who is going to exploit that? How do we exploit that? It's not exploitable. Just let it go. Don't bother them. Go and ask them to fix the high risk issues, right? That's important, not the low risk that nobody cares about. Something happened. So context and high fidelity, actionable feedback. This is the key part of DevOps, and this is the culture that we need to build and teach our security folks how to do it. So what it is not, DevSecOps is not a one-size-fits-all. It's not one tool. You cannot buy a DevSecOps tool from a vendor. You cannot hire a vendor to do the DevSecOps for you and then just come in for a week, build it, DevSecOps, and then leave. You can get some assistance. So you can buy some experience when you're learning. Like, you don't know how to do things. You can hire someone to teach you a little bit. But then when you're off your training wheels, that's on you, right, to continue that culture. It's not just about bolting in some tools into the CD pipeline. You really have to work with developers enough of just telling them how to, what to fix. You actually need to work with developers on how to fix. You have to sit down with them and write code with them. They don't know. They don't know what SQL injection is. They don't know what cross-site request forgery is. Sometimes they don't know what cross-site scripting is. They're like simple things, right? They don't know, and it's all right. They are not security professionals. If they don't know that, you're failing at doing your job, right? You're supposed to train them and teach them how to do that. They are very good at writing code. Maybe I don't know how to write code as fast as they do, right? I know how to write some code and can Google it, but hey, it's not vendor driven, right? So if someone shows up, hey, I have this awesome product that does DevSecOps, they're probably lying. Be very careful with that. And they are not compliance driven. You're not doing DevSecOps to meet compliance requirement. You're doing it because you care about security. You care about your customers. You care about your data. And compliance is a consequence of that. Eventually, you're going to be compliant with a bunch of standards. You can put on your website all sorts of badges in there. But it's not compliance driven. So I kind of talk about this a little bit before this slide. So you make friends with DevSecOps. You sit with them. You share lunch with them. You talk with them. You write code with them. You help them automate things. If they don't know something, you teach them. If they have questions, you're available to help them. And you're part of their daily, day-to-day work. So you join their scrums, you see what features they're building, you provide some feedback, you give them a little bit and they give you a little bit, right? And security team needs to learn to code. Like seriously, we need to. It's very bad that people doing application security, any type of application security really doesn't know how to write code. Like you don't have the respect of the developer. Like this guy doesn't even know how to code. How is he gonna teach me how to make my application more secure, right? And this is very important too. We need to eat our own dog food, right? Like we cook it and we throw it at the developers. Like, hey, this is 200 pages policy that I wrote. It's awesome. Looks awesome when I put it in my resume. Nobody want to read that. Like, seriously, do you guys remember everything about the last security policy you read? Nobody remembers that stuff. Like, let's try to make this better. And eventually security will become everyone's responsibility. Just like you help people fix things, now they are also responsible a little bit for the security because you're doing it together. You're no longer reactive and you start planning for stuff, right? You plan in advance. What if my customer types this? Well, I think they're going to type that, so I just put a check in the code, right? You start being preventive. There is no more last-minute policy security enforcements. There is no more signing waivers and getting dispensation for critical and high risk. Like, eventually you're going to have that situation, but it's not very often because you plan for it. You plan for everything, and eventually you won't have that situation, hopefully. And then this is very important. It's very important to me. It changes the company culture and brings security team to front and center as opposed to a hated team in the background. And when I say hated team, it's difficult being a security consultant or a security analyst. I had colleagues quit. Like, hey, I quit. I know how to do some coding. I'm going to write code. Like, enough. Like, people I don't like walking in and people looking me sideways, right? Like, they don't like, it's like I'm destroying their baby. I'm killing their baby. They're writing beautiful software and I show up every time to say it's not good enough, right? So I had multiple colleagues quit because of this. They moved, like, there's one lady, she moved to Australia. She started a coffee shop in there. She doesn't want anything to do with IT anymore. Seriously, it's crazy.
15.
Sorry?
You're 15.
Oh yeah. Well, very brave of her to do that too, right? It takes a lot of courage. Anyway, So when you talk about DevSecOps, we learned that we kind of mix everything, right? We have this cross-functional team. You help people write code, people help you secure things, you help operations run their software. So you have to learn a little bit about their domains, right? So here, I don't know if you can understand this chart, but it's basically the idea here is that dev is going to have 100% development, and they're going to know 60% of security and operations, right? The colors are not very good, so I don't know if you can make it up, the different colors in the chart. So security knows, it owns the security domain here, right? So I own my security domain 100%, but I spread my knowledge so that development and operations know what I'm talking about. So if I show up and say SQL injection, they know what I'm talking about. They know what it means. They know what is the result of that, right? And same thing with operations. If I show up and say, hey, your Windows server running SMB v1 needs to be updated, and this is the reason, you're going to know what you're talking about. Like, hey, you can hack that stuff. You can have ransomware. You can do all sorts of things. And then you have their respect, because they know you're not just enforcing your agenda to look good and get the bonus at the end of the year, right? You're actually helping secure their environment. That's going to prevent a lot of trouble in the future, right? Potentially prevent, because you never know. Like another excuse that I have is, well, we've never been hacked, so I don't really care about that stuff. We've never been hacked, so why you're stressing so much about this? So if they understand, if they learn what's going on out there, then they're going to respect you more for that. So we talk about DevSecOps, it feels like one person, right? It feels like, hey, I'm security warrior, I'm going to secure everything, right? Do everything. In fact, you actually still have your normal security organization, like bigger, like a smaller organization don't have all this, right? You have a few people, a smaller team that does a little bit of everything. But bigger corporations, they have security engineering, you have your security testers, you have your security operations, you have your compliance team, you have your security research. So you have all that stuff. So it doesn't mean it goes away with DevSecOps, and then you have all people writing code and sitting down with developers. That's not really how it works. So I kind of split this into, so everybody's DevSecOps, right? But then you have the main security roles and the supporting security roles. And they kind of work in pairs. Yeah, you can say that. So security engineering is going to work more on automating things, right? Writing code, integrating tools, working with development, experimenting with new stuff, testing new functionality, new scanners. And then on the security operations, you still use those tools to monitor things. You may generate requests for this team, like, hey guys, maybe it would be good if you can automate this task that I have to do it manually. And they're still going to detect issues, report back, feed into the pipeline, and their work is mostly contained. So the development that goes on in here is, well, I deployed this new container, this new version today, and I noticed some weird pattern here in the network traffic. So I'm going to investigate what's going on. I'm going to identify what's going on. And then I'm going to roll back because, hey, maybe someone is trying to get in on this new port that I opened. I don't know what's going on here. I'm just going to roll back to the previous version and until I figure out what's going on. So I'm just going to contain and then report back to security engineering to see what's going on there. At the same time, you have the supporting roles. These guys are still going to manage the security program. They're going to come up with training for the organization, right? This is not necessarily security product development. This is more the corporate security policies that you have, right? Train people, those trainings that you do when you join the company. So these guys are responsible for it. And then when you need to have compliance requirements and all that, they're going to communicate that to security engineering, and those guys are going to translate those requirements into code and automate into the pipeline. Same thing with security research. So you may have people taking input from operations, like, hey, I got these files uploaded, we don't know what it is, it looks like malware, maybe some new variation of malware, or we notice some trend that people from Russia are attacking our servers, so maybe we should talk with security operations and then we should contain that, block some specific region, or do something in the system to make better security. Very big organizations have this. Smaller ones, maybe you have operations and research on one side and compliance and engineering on the other side, like 2 or 3 guys. So it depends. It depends on the organization. But nobody's going to lose their jobs if you transition into DevSecOps. So one of the key things that we talked about is the shift left, right? So it kind of solves the problem that when we get about here in the release or about here on the deploy, security penetration testing teams find bugs, like critical stuff, and then we go back to management and they say, well, you should have told me earlier. How come you guys come in now? We go live in 2 days, and now we have to fix all this stuff, right? You should have been involved earlier as well. So the blame keeps shifting back and forth. Like, you should have involved security, but security should have shown up and make themselves available to help develop this stuff. So the shift left is basically those meetings that we talked about, like you join the development and you're part of it, and then you account for everything. You bring your requirements very early. Since everything now is code, you write code, so you plan on what you want to do. The developers are writing their software and the product, I guess, delivered to the customers. And on the side, you as a security person is automating stuff and making sure that code is secure. So you automate your scanning tools, you automate your policy, your checks, your flags on what builds are good, what builds are not. And the focus here is, well, first you need to have a very clean, objective assurance criteria, right? It's not, I don't like this guy. For this guy, I won't let any medium risks go live. But this guy is my buddy, so he's got some high risk, but it's fine, and I trust him. He can, here, stump his software, you can go live, it's fine, right? So none of that anymore. It's code. Code is binary, yes or no, and then you have a very clear assurance criteria. If it fails, it's going to show in the report why exactly it failed, and then people can act on it and fix it, right? You can scale. So if you build one pipeline and you build the code properly, so you have the knobs to adjust what type of, ideally you would have that to adjust how much security you want to enforce for a given product, right? So if you want, it's a very critical product, you want a lot of security. Let's say you want assurance level 3 or level 4. So you just change the code, change the pipeline configuration, and now the checks are going to see if you have any low or medium or high critical findings, it's going to flag it as bad. So zero tolerance. I only accept a clean bill of health for this software, otherwise I won't let it go through. If it's just an internal application that we are not really deploying anywhere, we're just playing around, then I can lower it a little bit. It's fine to have low and medium risk issues, but I won't accept any higher critical. It's scalable, it's code. So you can duplicate that however many times you need. So once you build the first one, now it's easier to maintain, right? The code itself, the checks can be audited. So if you don't trust your security analyst, you can look at the code, see what exactly he's doing, right? What am I checking for? If your management wants to see, like, hey, how come some bug bounty guy reported this from the internet, identified this issue on the internet, and we didn't catch this vulnerability in our code, in our pipeline. So you can go and look at the code, see where exactly your security checks are failing, and hopefully improve it. This is what this is about, improvement, continuous improvement, right? And you automate the certification, so only good, secure artifacts are published. And you automate for the operations as well. When things go back, you need to have levers that you can pull and push. So you can roll back, you can recover, you can back up, you can restore, you can destroy the whole environment and publish everything again, as long as your data is sane, right? So this has to be accounted for from the beginning. So if you decide to build your hard-coded encryption keys and then you have to destroy the environment, well, the encryption key is going to go, right? So now you create a new environment, you're going to put a new encryption key in there, it's not going to be able to load that data, you lost the data, right? So you need to account for that when you plan that security. So now you see it's not very easy, just do key management. You actually have to manage stuff and write code for that. And that is not very easy. And you have continuous monitoring and response. This is the normal security operations. It's just a little bit easier because everything, it has the proper hooks for you to put your tools in there. When you deploy it, everything is hooked automatically. You write a code once, and it just works, ideally. Ideally. It may not work the first few times. So I need to start, right? I want to have this CI/CD pipeline. I'm gonna use the cloud. What do I need to focus? And I borrowed this from this guy's this website, DevSecOps. There's some really awesome people maintaining this. You should go and take a look. They created this pyramid that shows by level of importance. So the base of the pyramid is the most important things you need to look at first, right? So in the cloud is mostly about zoning and containment. When you hear that something went wrong, some data leakage in the cloud, is usually, oh, S3 bucket was public with all the information on AWS. There is no amount of code that you can write in application that will protect you from that. That's the configuration of the infrastructure itself. You fail to contain, you basically publish your data store openly on the cloud. People are going to find out. Like even if the URL for your S3 bucket is a lot of numbers and letters and it's very random, people are going to figure out. There's no security by obscurity, doesn't work. So this is the most important thing you need to do. Second most important is asset management. Do we know what exactly is being deployed? Like, do I really need this container? Do I really know what's built in this container? I'm just pulling containers, Docker files from the internet, right? Do we inspect it? Do we trust whoever like anybody can just go and create a Docker file and publish in the repository. It's public, right? And just publish anything in there. And people are using it without checking what's being, when you build that container, they don't look what's being pulled from there. So you need container security and asset management. It's not just what containers you built and put in the cloud, but also what's inside that container, what's inside that software, what open source libraries or even paid libraries. If you buy third-party products or licenses, what are you building into your software, and is that secure? So there is all sorts of security products that you can use to identify this and secure this. I think a while ago, Farshad did a presentation about Docker security, which was very interesting. Maybe you should go refer back to that one, because this is all about asset management. And then, of course, we have logging. If I don't have good quality logging, or if I'm not looking at the logins, or if I don't have the tools to cross-reference the information, how am I going to secure this? Right? I don't know what's going on in my environment. I have nobody looking at it. So you need very, very good quality logging. And this needs to be built into the application. And then at the top of the pyramid, you have authentication and encryption. But if you have to focus on something, start right here. And then build up the ladder of security, right? So there are still challenges, even if it's DevSecOps, it all looks nice and it seems like it's going to work, right? But then our automated scanners are still finding million issues every time we run it, right? False positives everywhere. It's very frustrating. My monitoring tools are going to generate lots of alerts. If it might be something that's not configured properly, or it might be that's just receiving too many alerts and someone has to filter them, right? And tone it down a little bit into actionable items. Otherwise, if people receive a bazillion emails every day about security alerts, they're going to just create a rule on Outlook and route it to some folder. That's it. They're going to forget about it. It's not going to happen, right? Another challenge is, well, sometimes, ideally, we want to stop saying no and start helping people find solutions, right? It's not that, no, you cannot just build that. Yes, you can build that, but you need to do some additional security, and then you can build that, right? We need to shift our culture a little bit. But sometimes you cannot just build that. There are some things that you have to draw the line, and that might be a constraint sometimes. You still have that. You have to do it sometimes. Sometimes critical decisions are made by higher management and don't really involve security. So I don't know how to solve that one. If you guys know, let me know. We can chat after this presentation. I would love to know how to solve that. And especially when you have legacy software where you have development that is already ongoing, if you have a large piece of software, a large code base, you might have some significant security issues in there that need to be resolved and need large changes. So convincing people to actually do that might be a little bit difficult, right? Just funny, a little cartoon about a denial of service into just the case that I mentioned, 12.5 million vulnerabilities, crashed the email and ticketing system because way too many issues. So this is a classic example that the attempted cure is actually worse than the disease. So one of the solutions for this is basically this security funnel, right? This is also, I forgot to put the DevSecOps website. This comes from one of their slide decks. So you have all sources of security events in here. Pentest is going to generate reports. The Red Team is going to generate reports. Nessus is going to monitor your infrastructure. If you have any servers in there, Nmap is going to map your services on the network. You have Zap running as a proxy to capture vulnerabilities on your application. Then you have your static analysis, dynamic analysis. You have your normal log monitoring and other events. All this is going to generate thousands, millions of security warnings, and you have to somehow correlate them. So usually people use some Splunk or something similar to make correlation of all this data and aggregate data into a more meaningful information. And then you input this into case management, and it feeds into the developer backlog. So it's a funnel because the idea is that you start with 1,000 and you end with maybe 100. So don't just go flat here. Like take 1,000 inputs, just create issues, and then developer has 1,000 defects. they're going to ignore that. So important thing here is that the security features or defects, they need to be actionable. The developers actually need to know what to do. You cannot just say some gibberish in format of defect and they're going to read that. It's too difficult to understand. They're going to just ignore it. It has to be easy. So finally, how does this security pipeline actually looks like? So there is no recipe or standard security or DevSecOps pipeline. You can Google this term, DevSecOps pipeline. You're probably going to see this image or many more similar to it. All these tools here change. You can have GitHub. You can have all sorts of other repositories. You can have, so check marks here is a IDE plugin for scanning code. So it's right there on the developer interface. It's easy to see. Doesn't even go through a scan. It's pretty much real time. You have GitRob that filters and monitors the files that are committed to your code repository for sensitive information. So if you have credentials in there, it's going to catch in here. You have your Splunk to aggregate data from your CI/CD. Then you have all sorts of tools when you're running. So you probably have scans in the source code here, and you have dynamic scan, automated scans on the when you have the test environment. So you spin up the test environment, run some of these tools. This Gauntlet is a very cool open source tool. You can integrate. They support a bunch of security tools, so Nmap, Zap, Nasus. They all integrate through this tool, and you get reports, aggregate everything, cross-reference is really awesome. And then here you have your artifacts, right? So once you built your containers, you still have to scan. So here you're testing your code, the code that you wrote, your team wrote this stuff. Here is the stuff that you're pulling. So this we start shifting into that container security sort of thing. So you have your repositories, your integrity checkers, and all sorts of things running in here. And then by the time you deploy, you start linking into the monitoring tools. And then you have here your Metasploit for automated penetration test. You have FireEye for application scans. You have Splunk and Evident.io for aggregating more data. These tools can be anything. It can be anything you want. There is plenty of open source tools. There is plenty of offerings from vendors. So it's up to you and your budget to define what exactly you need. So maybe start with the open source ones. I have a list at the end of the presentation of a bunch of tools that can be easily integrated into the build pipeline. Where can I learn more? Like I need to, if I want to create my own pipeline, I discovered that OWASP actually has this cool project. I think it's some guys in Texas. I don't remember their names, but I appreciate that they started putting together, they are evaluating tools that are good for integration and security in the DevSecOps pipeline. And these charts are actually from their project. So they are ranking all sorts of tools and where they fit into the pipeline. So you have Brakeman for those who write code in Ruby on Rails. It's a sort of a security scanning tool for that. You have Fortify, Checkmarks, Veracode, Contrast. You have all sorts of security tools for different stages of the development lifecycle. And then they created kind of a template, really, of what would you need. So you would need some assessment, you would need some analysts to remove false positives, you need developers to remediate issues, you need to log stuff on your GRC tool, you need to track defects, metrics, and all that. I feel that this is a little bit outdated. I think it's from 2015. So maybe use it at your own discretion, how to build your template. There is not really like the new concepts now that there is no real template. You just build whatever you need. You start automating whatever you can and build whatever you need. So there is some, this is from the DevSecOps. DevSecOps has a manifesto just like DevOps. And these are some of their values and cultural changes that are needed. So basically, always leaning over instead of just saying no. And this is a really important change. You start, is actually what prevents security professionals from integrating and working together with developers. They see, I will not even talk to this guy. He always says, no, I already know the answer, so I'm not even ask anything. Data security science over fear, uncertainty, and doubt. So if you don't know what's going on, go learn. Ask the developers. Ask the people that manage that solution. They know. They can tell you about, and then you can make more better decisions when you make a call. You grant release for security release, or if you deny a release to go live. Start contributing and collaborating with people instead of just showing up with a checklist of requirements. That's very important, as it relates back to eat your own dog food, right? Start helping people build it. Start building patterns, right? So if you automate something, make it configurable and scalable so you can reuse it. So next time you need to secure a different project, for example, you can just show up with this, like, hey, I have a bunch of security requirements. These are the papers that I need to make happen, but I have a solution here. I have this code I wrote, I automated for that other project. It works fine. It's easy. It doesn't get in the way of your development, right? Business-driven security scores over rubber stamp. So start understanding what business want out of the projects. I understand that policies are nice and they give you that protection that, hey, I'm making this decision because this is our policy. But sometimes you need to be flexible. More and more and more, DevSecOps is all about flexibility and understanding what's going on, so you don't have a very rigid policy. You have more flexible policies that take into account the business needs as well. Red and blue team exploit testing. So we didn't talk much about red and blue team exercises. So usually when you have a red team trying to attack your application and you have a blue team trying to monitor and see if they catch what the red team is doing and prevent them from getting in. So you see a sort of a capture the flag in production. It's always fun. And that gives you real scenarios. It's not just, you can trust the scans to a certain point, but sometimes they are too generic. They are just come up with the scenarios and things that are never going to happen. Like, they don't account for everything into your environment. So this is preferable over the scans and theoretical vulnerabilities. You need monitoring. You need to be ahead of the threats. And what we don't want is just be informed like, hey, we got hacked, just like happened this week with some banks. They they got informed. They didn't even notice. They didn't know. They got a notice. They got an email from the hackers like, hey, we hacked you. You didn't know? Like, we spent so long doing this. We extracted 90,000 accounts, like full profile from your bank, and you didn't notice? We had to tell you that we did this and then demand a ransom? So that's monitoring. Like, if they had monitoring, like, hey, this IP is, or maybe this set of IPs or this region is accessing all these accounts, something is wrong, right? And then block it. They would have maybe reduced the impact a little bit. I don't know. The other thing that is very interesting is sharing the information that you have. Sometimes I've seen people just keep this tool, and I have this script that if I don't find anything in the report, if I don't have anything in the scanner, I'm just going to throw these vulnerabilities in the reports just to show that I did some work and I found at least 5 vulnerabilities that need to be fixed. I don't remember ever seeing a clean vulnerability report. It's fine to have clean vulnerability reports. You share that information with people, and ideally, when you run the scans, you don't have any. That doesn't mean you didn't do a good job. That means you did a great job, because you don't have any vulnerabilities to report. You prevent everything in advance. And this is a big cultural change. I've seen security teams that they count their performance based on the number of vulnerabilities that they can find, which is completely wrong. Compliance operations over clipboard and checklists. So you need to let people know what you're trying to be compliant with and why that is important, and you need to work with your teams instead of just showing up and doing audit. Audit is after you did all the legwork and teach everybody and make sure everything is implemented. Then you can go audit and see if everybody did a good job based on that information. So I'm way over my time. I'm going to end the presentation. Thank you very much for listening. And I think now we can open for questions, right? If you guys have any questions for me.
Yeah, thanks very much, Roger. So if anyone has questions, I can bring the mic. You just have to speak into the mic so that the audience that are not here can hear you as well. So,
Yeah.
Thanks, Roger. So with regards to the counsel that you give the development team,
Yeah.
how prescriptive is that advice? You know, obviously you mentioned the fact that you need to be able to write code.
Yeah.
But their job as the developers are really the code masters.
Oh, sure.
So how prescriptive is your advice? Like, are you?
Well, you're not telling them write this 5 lines of code. It's usually you have to work with them to teach them what the issue is. Usually they don't know the answer because they don't know what the issue is. Like the cross-site request forgery. Like, a lot of people don't understand that. Like, hey, how come someone will submit this GET request? It's supposed to be like this. I don't know why you're raising this as an issue. It's by design like this. And then when you explain that the session gets stored in the browser and it gets sent when you click this GET request and it gets processed in the back end, they click. Oh, hey, now I see the problem. Yeah, we can solve it. We can do this, and we can solve it. So you don't prescribe the solution, but you make sure that they understand what you're talking about. A lot of people don't understand what you're talking about, and they are ashamed of asking. Like, it's human, right? They don't know. Maybe they don't understand. They are afraid that they will not look very smart if they ask, and that shouldn't be the case. Like, you need to have communication. You need to be able to be comfortable with your colleagues, right, and ask questions if you need to. Thank you. Thank you for the question.
Yeah. So just regarding about Dockers, you were mentioning about Dockers and containers.
Yeah.
So I'm working on them right now.
Ah.
So one of the things we can use is the Center of Internet Security. They've released the benchmark, and that's why I've automated it as a script.
Yeah.
So when I'm building a Docker, I run that script, and it validates against all these benchmarks, all the controls. And then when you
Fantastic.
build a master container, and then all your other containers, you can put them as a template against that. Another thing you can enable is a content_trust parameter. So if you enable that, which is disabled by default, but if you enable it, the content that's pulling is the digitally signed, so you can compare the hashes.
Exactly.
So I just thought I'd throw that in.
Fantastic. Yeah,
And that's what I'm working right now. I'm doing the security architecture for Dockers and the containers,
Yeah.
and this is the kind of stuff we're doing for the control.
Yeah, that's the two main things that we always recommend to do. Thank you for providing that input. And you mentioned CIS benchmark.
Yes.
So they have it for Docker. If you guys like Kubernetes, it's really popular.
Yeah.
They have a very good one for Kubernetes.
That's what I'm working on as well, the Kubernetes cluster.
And they have all sorts of
Yeah.
other technology. They even have for IAST, Windows,
Yeah.
Linux. They have
Yeah.
documents for everything. The benchmarks, I don't think they
They
have
can
automation for
act-
everything.
They actually provide you, if you contact them, they actually can send you the benchmark as a script, as a shell script.
Oh, really?
And then you can put it, embedded it as part of the container build.
Yeah.
And as soon as you run the container, install the container, it runs the script, and it tells you all the warnings and all the
Yeah.
greens and all that.
Yeah.
So it's very easy to use.
Fantastic. Yeah, that's fantastic advice. Thank you very much. I think I actually put some links in here. Yeah, Kubernetes, CIS Kubernetes benchmark is right here. I should have put the Docker as well. It's really cool. Yeah, sure. Go for it.
Thank you. I can see this working in like a big company.
Yeah.
But how about like a small company or startup? I think like this is too bolted to be implemented in a workflow of like a small company like a startup. How do you envision like a startup benefiting from DevSecOps?
It's for small companies. It's honestly is not too bloated. It's however you decide it's gonna be. If you have no security practice at all, you don't have anything, then you cannot really have DevSecOps, right? You need to have some sort of security practice.
If I can just talk on that one, I'm actually the lady that just left. She's at a startup I'm working with. It's an 8-person startup. She's our QA lead, and we're putting automation in. So we're very lean, very low amount of staff, and all you need is having some sort of continuous integration, continuous delivery, right? If you have that automation, tools like OWASP Zap can easily be integrated into your automation pipeline, into your CI/CD, and catch 80% of the low-hanging fruit. Now you've done DevSecOps, right?
Yep.
So you can do it. You don't have to go super heavy, and have all kinds of reviews and heavy processes and stuff like that. But you can always start with automation and putting those tools, the free tools that are available, into that pipeline for sure.
I don't think you're shifting all that because you really should have the developers be part of this. So I was saying, I don't think you're shifting left enough. So as an example, you're showing tooling that can be used, and everyone will have their own favorite tooling as an example.
Sure.
But like you can be using static code analysis like SonarLint right into your IDE. So the developers don't have to fear security. They can actually be notified of poor coding practices right then and there. Right into their build automation when they do check-in. You could have gated check-ins to your source control that would run your scans of the code before you even check it in. So there's no security person needed at that stage where the developers could actually start getting early warning of poorly designed. You can't talk about security if the quality of the code is suspect, and the quality of code can be validated a lot sooner in the pipeline. You can get things like TSLint and SonarLint and everything in VS Code for free. The developers never have to be interfaced till they come and ask the question, I don't understand what this means. Now your DevSecOps person is actually an advocate for helping them rather than being a detriment. And I don't see that in this pipeline the way that this has been shown. You do have your static code analysis and that later in the pipeline, but I think you haven't shifted far enough left. I think developers should be responsible just as much for the security pipeline, which comes from their code quality before it's even touching or being deployed.
Yeah, so this, I see what you mean. So this is usually, when I mean code here, this is exactly what you're talking about. So Checkmarx I know Checkmarx. I don't know the tool you mentioned.
Sonar Cube is the.
Oh, yeah.
Sonar Lint is the linting tool
Yeah.
inside the IDEs. Sonar Cube gets you.
Sonar Cube, right? Yeah, I've
reiterate
actually
that.
heard about
Right,
that.
so Sonar Cube is an open source product. There's
Yeah.
no cost base other than
Yeah.
you need to set up the servers on there. It will actually do all the static code analysis and look for things like code smells and look at for what's called cognitive complexity. So it's code that developers like sometimes to write what they think is elegant code, which is not manageable code later, right?
Oh.
And so it looks for when you look at most security vulnerabilities that are found in code, they're typically because of developers being overly ambitious in trying to build something which they don't understand what they're doing.
Yeah.
Or worse yet, they don't understand the security implications of their decisions on what they're doing.
Yeah.
And when you're starting to talk about what can they do, the shift left all the way. Sonar Lint is actually, so if you use like they say the Microsoft pipelines like Visual Studio Code or using Visual Studio itself,
Yep.
there are plugins that are right in there. As you're writing the code,
Yep.
it tells you of defective security code.
Yeah,
Right?
I'm familiar with this too.
Right.
Checkmarks
And a lot of these
Veracode.
things are
These
free.
are paid out
Yeah.
for third party paid, and they cost a lot of money. So this is
Yeah.
a very good.
So
I
and there's
didn't know
tons of
about it.
linting
Yeah.
tools out there that you can get for different IDEs and you can run it right in your build automation that's right on your desktop if you need to. So
Very,
it's
very
something
cool.
to check out. Sonar Lint to Sonar
Yeah.
Cube and we use gated check-ins for that on VSTS, so it won't even deploy if it fails the checks.
Yeah.
So the DevOps people don't even have to look at it. The developers will know, and they'll be smacked in the face for doing poor things that are against policy before it even gets deployed.
Yeah, that's fantastic. Thank you very
And
much
you
for
can
that.
do that on a two-man company. You don't need.
Yep, awesome.
Thank you. Any other questions? All right, if there are no other questions, we'll wrap up the session.
Yep. Thank you very much, guys. I think it was very good. I learned.
Yeah,
I
always learn what we present.
I definitely learned a lot when I wrote this, and I appreciate the questions and the advice. Like, it's very good, very beneficial for all of us. Thank you very much.
Just a couple of George for doing the live streaming. Thank you, George. To our volunteers, Jivan, Robert, and everybody else that helped us make this happen today. To Microsoft Canada and Andrew and Tanya, who helped us get the space. I'd also like to put a call out for speakers. If you are interested in being one of our speakers for future OWASP events, please feel free to let us know or let me know. Give us a shout on Twitter, drop me a line, come see me. Also, check out our OWASP Vancouver page. So if you just go to the main OWASP page and look up the Vancouver chapter, you'll find us. We post all of the information about upcoming sessions, as well as you can subscribe to our mailing list so you can be kept in the loop as to what's happening. Other ways you can keep in touch is follow us on Twitter. It's just OWASP Vancouver, so real simple. And you can also subscribe to our YouTube channel, which George has kindly set up for us, which will have all of our previous sessions on there. And you can also join the conversation on the Mars Community Slack channel. If you want to know how you can join that, just go to fourthplanet.ca/Slack. Put your name and info in there, and we will send you an invite, and you can get on there and join the Vancouver community of information security. So once again, thank you for coming, and we'll see you the next one. Thank you.
Thank you.